and IT Capstone presentations for the spring 2018 semester. So again, as we mentioned this morning, I personally did want to reach out and give you my thanks to being a part of the advisory board, being that constant affiliation to Stout, despite many alumni already graduating or some new faces coming into the advisory board. We appreciate all the input that you guys have to offer, and we're really happy that you're here today. So we have 4 presentations prepared for you. Up here are the sponsors for these presentations. So the first presentation will be our presentation. We're sponsored by Dell EMC, and we'll be talking about the automated deployment of virtualized environments. Following our presentation will be Target Corporation, talking to you about some DevOps utilities such as Chef, Kubernetes, Ansible, and Docker. And then after that, we'll have the Menards sponsored presentation. We'll be talking about Cisco VSS and a potential implementation for that at Menards. And then finally, Heartland Business Systems will be presenting about deploying a small to medium-sized business in AWS. So again, really happy you're here for these presentations, and we hope you enjoy. One note too is, as we mentioned earlier, most of the students that you'll be seeing today will be graduating tomorrow. So those comment cards that you have are pretty vital to our graduation. So go ahead and give your honest opinion on those. Yeah, that'd be great. So again, segueing into our presentation. Again, we're the Dell EMC sponsored team, and today we'll be talking about the automated deployment of virtualized environments. My name is Pierce Lanu, and I'm the team lead.
I'm Kevin Moore, I'm validation lead.
My name is Eric Etler, I'm the systems administrator. I'm Forrest McLaughlin, I'm the storage and monitoring administrator.
And we'd like to give a quick shout out to Dell EMC, our sponsor. You guys were honestly the best team to work with, in my opinion, just because we only worked with you, so you're the best, right? But you guys were fantastic to work with you, prompt with email, prompt with your meetings. When we reached out to you for guidance, you guys gave your honest opinion. You gave us a direction to go in, but you didn't tell us what to do or how to do it. So honestly, you guys did a fantastic job. Really happy. You couldn't have asked for anything better. So thank you very much.
Thank you.
Here's a brief agenda of what we'll be talking to you today about. First off, we have our fictitious customer called Foundry DataWorks. We'll be talking about who they are and what issue they're having. Then we'll be talking about our solution to that issue, which is VRA. We'll cover more about what that is in a moment. And we'll address how that achieves how that achieves Foundry DataWorks business goals. Then after that, we have a live demonstration prepared for you. We'll be covering the end user experience of VRA and how the user interacts with it. Then we'll also be touching on the administration and the execution of deployments and how that works. Then finally, we'll be wrapping up with where we spent our hours throughout the semester and some lessons we learned along the way.
All right, so who exactly is Foundry DataWorks? Well, as Pierce said, they're a fictitious company. They frequently develop new technologies and test technologies for their customers, and they would have what we call a high churn testing environment. They are frequently re-imaging bare metal solutions. They're installing hypervisors OSs and putting applications on top of them. This is eating a lot of their time, which leads into our problem statement for the project. They're looking to slim down that amount of time they're spending on these deployments. They want a single one-touch deployment and destruction solution to bring back all that time and resources.
Now through our research, we found that there are 2 candidates for our solution, the first being VRA and second being OpenStack. Now taking in the needs and concerns of Foundry DataWorks and having that want for that one-click deployment, one-click teardown, we found that VRA was the best solution for them. Now you're probably wondering, what is VRA? Because that's all you hear about. Well, VRA stands for Derealized Automation. It's a software platform that enables the automated provisioning and management of applications, containers, infrastructures, and IT services. With those alone, Foundry DataWorks can see themselves cutting their operations costs and then eliminating that time-consuming labor process that they're currently doing. It's important to note that VRA is a VMware product and that it's easily integrable in the vSphere suite. And VRA is also in support of multi-vendor and multi-cloud environments. And just to give you an idea of how multi-vendor friendly it is, here's a picture for you. Starting at the left, we have the infrastructure. So if your physical infrastructure consists of multiple vendors, just know that VRA can easily be integrated into there. Cloud support, we have Amazon Web Services. That's actually a presentation that's going to be given later today. Container management, you can see Docker and Kubernetes. Imaging, you can see Chef and Ansible. That's also a presentation that's going to be given later today. So this just shows you that you can integrate VRA easily into your current environment. And below are just a few of many companies that are using VRA as their cloud automation solution.
All right, this graph here shows the main problem that Foundry DataWorks is having, and that is that it takes a long time to complete a bare metal deployment. first have to get all the equipment you need together, then you need to provision it for whatever purpose it is, and then finally you have to install all the software on there, and that leads to a lot of downtime. And at that point, it only serves that one purpose. You can't do anything else with it, and if you need to do something else with it, you have to go through that entire process again. It gets to the point where it's almost like you've hired on another employee, and when you want to get rid of that employee, you have to give them like a severance package or something. But with VRA, it's kind of more like hiring a temp employee. It only takes like 15 minutes for one of our more complex packages to be fully deployed, and when you don't need it anymore, you can just touch a button and it's gone. The process starts without you doing anything else besides that. So now that we know a little bit about VRA, we can kind of get into some of the infrastructure that's behind it. Because VRA is not just an application you can install on a computer and then immediately does its job. It needs infrastructure. So our infrastructure has two tiers to it that allow us to use our solution correctly. So our first tier is the virtualization, which is all done through the VMware vSphere suite. So that includes ESXi and vCenter. And these two tools allow us a centralized place to administer virtual machines as well as create templates, which will later be used by VRA to create blueprints that the users can then deploy when they log in. The next tier is our networking, and that we have a mixture of virtualized as well as physical. So all of our virtualized networking is done through VMware's NSX, which is an extremely useful tool for virtualizing layer 2 and layer 3 networks, as well as the edge routers, switches, and firewalls that come with them. Then, of course, we have our physical, which we'll talk about in a couple of slides.
So kind of touching on the first part that Eric said, virtualization aspect of VRA. So right now, Foundry DataWorks is kind of stuck in a prehistoric era in relative terms to IT. They're pulling bare metal servers off of a shelf, they're installing a single operating system on those servers, and then they're putting their applications on top of that. And as we know, virtualization has been around for quite a few years, and no longer do you need to have one piece of hardware do one purpose. Now we can instead take that same piece of bare metal, we can install a hypervisor on top of that, and then on top of the hypervisor is where your OSs and your applications sit. So now instead of having one application and one operating system on one piece of hardware, now you can have upwards of 6, 12, 20, 40 operating systems, 40 applications plus running on one piece of bare metal.
Kind of jumping into the networking section that Eric talked about earlier. We can see how NSX works as our network. Starting at the top here, we have our external network, and that's coming into our physical router, which we'll be talking about in a moment. We'll take a layer 2 link down into the NSX edge, which at this point everything becomes virtualized through NSX and then through the bounding box. Moving down another layer 2 link into the distributed routing section. All of these routers and layer 2 networks underneath them are created on demand through NSX. And on those layer 2 networks, you can put your hosts, your VMs, your applications, etc. on top of that.
And I know this illustration can be a little bit daunting and confusing, so let's get more granular and focus on how the network works for a single deployment. Starting at the top, we have the existing NSX 8 edge gateway that's already existing and it's in charge of the upstream network. Now below our user deployments, we actually have two networking schemas for our deployments. If that user deployment consists of multiple VMs, those VMs will connect to a layer 2 switch, which will be made on demand, and then connected to the NSX gateway, which will then make that network private. And then we also have a jump box that connects to that private network and to our upstream. But if that user deployment has one VM, then that VM will just be connected to that layer 2 switch that we just made on demand, which is then connected to our upstream network.
So kind of touching on the physical side of our lab environment, all this equipment that you see up here was at one point donated by Dell EMC. Majority of the equipment we are using was just donated last semester in upwards of $500,000. So again, we wanted to thank you guys very much for the generous donation that Dell provided us. Starting from the top, we have our gigabit access switch. That's an S3048 with 10 gigabit uplinks. Beneath that, we have our two distributed switches. These are 10 gigabit switches with 40 gigabit uplinks. And then following that, we have our single PowerEdge R310. This is an older unit that was donated earlier, so we decided to install a routing software on there called pfSense, and we're just having that run as our bare metal physical hardware, or physical routers. Beneath that, we have 4 compute nodes. These are PowerEdge R630s. These are configured with 64 gigabytes of RAM each. And then beneath that, we have our storage array. That is an SC7020 configured with just shy of 21 terabytes of storage. Most of that storage is flash storage. So if you can imagine, all this hardware made this project run pretty smoothly, and we didn't have any issues with hardware, that's for sure. When we were configuring VRA in the early stages of this project, we were concerned on RAM just a little bit. One of our blueprints is using upwards of 30 gigabytes of RAM in the blueprint. So every time that blueprint gets deployed, it's going to kind of reserve that much RAM. So we decided to requisition an additional compute node from the C9T lab. It's just a standard DL380P that has 192 gigabytes of RAM. So that way we're set for RAM and we have no issues there. So now we have a live demonstration prepared for you today. This is a brief flow chart of what we'll be doing during the live demonstration. First, we'll be logging in as our fictitious end user, and we're going to get that deployment kicked off right away. And hopefully by the time that we finish talking about the second and third option, we'll have that deployment actually ready, and the user can go ahead and interface with that deployment all within this demonstration. The second part of the demonstration, we're going to showcase the administration side of VRA. How easy is it to make a blueprint? How easy is it to work with a canvas and dragging and dropping the different utilities in there? And finally, we'll be switching back over to the end user, and we'll be watching his deployment kick off on the back end, and what does it actually do in vCenter. And then finally, we'll be demoing the end user's options, how can you interface with it, get the console in, what options do they have there, and then we'll destroy it, because that was part of the deal, is that he can bring something into this world, he's got to bring it out. So here comes the demonstration.
All right, so moving over into the VRA web portal, we're going to see the Foundry logo up top, as well as some custom colors. VMware encourages you to make this your own. So we've imported the Foundry logo. Those of you in industry for a while, and they recognize it as the Foundry Networks logo. We repurposed it for our own needs. But today we're going to sign in as our fictitious user, Vinny. We're going to log into the web portal. And starting from the top left, we see his tabs. We have home, catalog, items, requests, and inbox. Today we're going to take a look at Vinny's catalog. On the left-hand side of his catalog, we have our service groups. These are integrated with Active Directory and allow us to separate what users see based on their user credentials. Vinny is a sysadmin right now, so he gets everything. But today he needs a CentOS machine with NAT, so we're going to click request on that. On this first page, he can enter a description and reason for his request if he needs it for his own purposes or the administrator. If he clicks on the machine underneath that, he can adjust the hardware settings as appropriate if his admin allows him to, but he's not going to do that today, so he's going to click submit. And you see it's been submitted successfully. It's been sent off to vCenter and NSX in the back end. And we're going to take a look at the administrative side of VRA. Here's.
Thanks, Forrest. So in a separate window, we're going to go ahead and log into our single sign-on page as administrator. And then we'll see that the administrator is presented with a few more options than compared to what Vinny had. So the administrator is presented with design, administration, and infrastructure tabs. So what we're going to do is we're going to hop into the design tab, and we're going to show you just what does it look like to make a blueprint. So here we're presented with our list of blueprints, and as you see, all of them are published in this case. We're going to go ahead and click the single Windows Server 2016 with NAT, and we're just going to use this. It's a basic deployment. The objective is to deploy a single Windows Server instance that's connected to 2 networks. So over here, we can see the different machine types that we have. As we mentioned, VRA is a multi-cloud and multi-vendor platform. So we have Amazon EC2 and Azure machines as options over here if you were to configure VRA to interface with those services. Also, we have Hyper-V, OpenStack, vCloud Director, vCloud Air, and if you have Citrix, Zen server machines. And finally, our platform that we're using is vSphere's vCenter. So we went ahead and we dragged over the vSphere vCenter machine type. As far as networking and security goes, if you have a network already existing and you don't want NSX to create any new layer 2 or layer 3 networks, that's just fine. All you have to do is drag over the existing network, and what you can do is you can then select what existing network in vCenter do you want to attach this VM to every time it's deployed. And then finally, we have our on-demand NAT network, which we are using here. So this is the on-demand, meaning that every time that this blueprint is deployed, NSX will create this network on the back end, propagate that to all your compute nodes, and ensure that there's connectivity no matter where that VM sits. So kind of jumping into the VM settings that we have, we're going to click our VM, and here we give it a name, a description. We have available reservation policies if we had more than one compute instance or source. If you wanted to, for example, only have this VM run maybe on premises instead of having it in Azure or Amazon, you would specify that policy here. I imagine some of you have seen some pretty cluttered vCenters before, maybe with 200 or 300 or 400 VMs, and maybe there's just no sense or manner to how they're named. So what we can specify here is a prefix that is automatically applied to each VM as it's deployed, so that way you can easily identify that VM in vCenter. And then finally, how many VMs is the end user allowed to have in this deployment? In this specific blueprint, every time that this is deployed, do we want to allow the user to be able to scale the number of VMs he has? Maybe he only needs 1 to start, maybe he needs 10 later. You can specify those values here. Hopping over to build information, this is where we specify how does VRA actually build this VM. And right now we want to clone a template, so we specify the clone action. It's using the clone workflow for Realize Orchestrator. And then finally, where is it cloning from? When we click this button, as you can see here, we have all of our vCenter templates available in here. So what this means is every time that you make a template in vCenter, you have to do nothing else to bring it into VRA. This list is populated from your available vCenter templates. So every time you make a new template, you spin up your new machine, configure it, sysprep it how you normally would. When you turn it into a template, it's automatically populated here. So we went ahead and we clicked the Windows Server template. Machine resources, here's where you can specify just how many machine resources is the user allowed to change on his deployment. So if you want to allow him to use upwards of 4, 8, or 12 cores, we specify that here. Same goes for RAM and storage. Speaking of storage, heading over here, this list is automatically populated from the vCenter template. Right now, that vCenter template for Windows Server only has a single 50 gigabyte hard drive. What you can do is actually allow the user to add more storage if he needs more storage later on. You specify those values there. And then finally, going over to networking, this is where when we dragged over the existing network and the on-demand network options on the left, this list is automatically populated. And then once you connect it to the VM, this is where you specify how is that address obtained. So right now, NSX has the ability to have DHCP on the virtual router, so we have DHCP set there. And then our upstream on-premises network already has a DHCP server present, so we specified that both of these would be DHCP. But if you wanted to assign static addresses, that would be done here. And that kind of wraps up the administration of VRA. Now we're going to hand it over and take a look at how that request is going.
Thank you, Pierce. Well, now that Vinny has requested for his CentOS machine, he's probably wondering, well, what's the current progress of it? So if he navigates to the request, he can see all the administrative requests that he can do, which is destroy and make VMs. If we go to the latest one, and then go to the execution information, you will see that Vinny has a clarity of what is going on in the background. The first few items are the networking portion of this blueprint, and the last would be the VMware, the virtual machine. But to give more detail, we can go into vCenter and see what actually is going on in the background. So starting off, once he hits that request button, vCenter is going to start by creating the networks of this blueprint. It's going to start first creating that layer 2 switch. It's then going to deploy a NSX router. It's going to configure that router into the IP addressing scheme that we specified. It's then going to start cloning that gold image for that CentOS machine. It's going to rename it, and then it's going to power it on. And then once we go back into there and click request, it would be done. But unfortunately for this time it's not, but it usually takes about 6 minutes. We've made multiple tries and it's always 6 minutes. Now I'm going to hand it off to Eric and he will cover the user experience.
Thank you. So we're back in Vinny's window, and we can see that we have the items page open here. Here you can see all of his currently active deployments that Vinny has access to. And if we wanted, we could click on here, the little arrow there, and then I'll expand it. You can see all the individual items that are within the deployment. Keep in mind that these items were all deployed without Vinny ever doing more than just pressing a button. So this was all deployed in the back end through vCenter and NSX. So we have the CentOS Linux distribution virtual machine here. We have the NSX layer 3 edge router, as well as the NSX virtual switch. And then we have the upstream connection to our own environment. So we can explore the Linux virtual machine by clicking on it, and we can see some options and actions that are available. So while this is loading, we're going to take a look at some of the actions that we can do. We can connect to the virtual machine using a HTML5 remote connection window. That's a lot very similar to how ESXi does it. We can also create snapshots, which we'll talk a little bit about later. And then the two options that I like are the reconfigure and reprovision options. Reconfigure will allow you to change your physical hardware settings on your virtual machine. So you can specify that you'd like a little bit more RAM, or you can connect the hard drive, something like that. But that's only available to you if your administrator sets it so that's available to you, as we saw earlier. The reprovision command, however, is a little bit different in that it immediately destroys your virtual machine and then redeploys it afterwards. So that's pretty useful in a case where one of your friends tells you to delete your systems32 file to make your computer go faster. Well, we have recruited for that. Not that it really matters because it's a Linux distribution, but you get the idea. So from here, we can see we have the General tab open, and as you would imagine, you can see some general information about the virtual machine as well as your hardware specs. So these would be what you changed when you hit the reconfigure button. We can go to the Storage tab, and from here, you'll be able to see all the hard drives that are connected to your virtual machine. And if you were to add or remove hard drives, it'd be reflected in this tab. We can go to the Network tab next, and here you can see the main IP address of your virtual machine, as well as any attached network interface cards, virtual in mind. Then we can go to the Snapshots tab, where if you created a snapshot using that action, it would show up here, and you would be able to rename it, change descriptions, delete it if you needed to, as well as go back to that snapshot. All right, so next thing we'll do is we'll actually connect to the virtual machine so that you can all see that we're not lying to you, it works. We promise it works.
We promise.
No, I swear it works, it's gonna get better.
Living live.
All right, here we can log in as our test user, and we'll get to a Linux desktop. And from here, you'll be able to do whatever the heck people use computers for these days. I guess you could open up your Linux terminal. You could also go on the internet and browse Reddit, maybe. I don't know. I'm kind of sick of looking at this screen. We've deployed so many Linux virtual machines that I'm just sick of it. So I think we'll just go back to the Items tab, and we can actually click on the deployment itself rather than expanding it this time. And we'll get some deployment-wide actions that we can take.
Just to prove to you guys that that top deployment was the one that we started a few moments ago. So it did finish, and now it's listed there. No lies. No
All right, so here we can see some actions, and we're gonna hit the destroy button, and that'll bring us to a page where we can specify like a description or a reason why we destroyed it. But we're just destroying it because we want to. So we're just gonna hit the submit button, and as you can see, it's submitted successfully, and that's all the user has to do in order to destroy a virtual machine. So at this point, we'll head back into the presentation proper. Before us, we'll explain some benefits and use cases for VRA.
All right, so some business benefits of using VRA. These top two, efficiency and agility, work together very well. We're talking about that one-touch deployment and destruction. Very easy for the end user to interact with, and it's fairly seamless and quick. Deployment's taken usually under 15 minutes, 6 if it's less complicated. Flexibility, next point. Talking about how versatile these blueprints can be made. As we said, they're populated by vCenter templates. These templates can be changed for a myriad of different reasons, and then they will be automatically populated back in VRA before you make your blueprints again. Control, talking about administrative use. As you saw, the blueprint creator is very, very easy to use. It's much like working as an actual architect. You get your spreadsheet, and it's nice to look at. Moving on to some use cases. As we talked about with Foundry DataWorks, they have a very high churn testing environment. They're regularly destroying and creating virtual environments. So this is very useful for them in this case. Next point, development and testing. When you're working with applications and software, sometimes they may not play very nice together. So if you need an isolated instance to test these applications and see how they interact with each other, that would be a good choice here for VRA. And then finally, in the learning category, in the CNIT program, we have advanced security. Frequently, students are downloading images and setting up their VMs more often than they seem to be learning in this environment, simply because it takes so much time. It's very similar to how our sponsor laid it out with Foundry. And being able to deploy these environments quickly and in the background while you're working on something else would make the learning process a lot easier.
So here's where we promised we would touch on where we spent our hours this semester. As you can see, we had a pretty strong ramp-up week. Week one, this is where we were familiarized with our statement of work, our hardware. We got to configure the SAN, which none of us had actually ever done before. So that was a small learning curve to tackle that as well. Then we presented our storage to our hosts, got ESXi installed on all the hosts, and that's all that we accomplished in week one. Weeks 2, 3, and 4 is where we spent most of our research period. Again, that was comparing VRA to other solutions out in industry. And then once we chose VRA, the end of week 6 is where we began to deploy VRA in our test environment. Week 7 is spring break. After spending majority of the hours in the first half of the semester, we all thought that we needed a nice rest and to rejuvenate and rest our minds. But those 8 hours there came from Forrest. He did not feel that. He felt the need to continue working relentlessly, so he put in a few hours every day over the break. And then finally, weeks 8, 9, and 10 is where we wrapped up most of the technical requirements of the statement of work, and we began to document what we had done and then start producing our white paper, which is where we spent the last few weeks. As you can see, there's a little bit of scope creep that happened towards the end, but I can't say that that's not typical. So finally, some lessons learned. We all got to know each other really well. We had a great time working as a team. We really got along well, and honestly, I think this was a fantastic group to work with, and everybody had a lot of laughs along the way. So as far as maybe a technical lesson learned, planning ahead, licensing can be tricky. I think that goes for nearly every product in industry, that sometimes licensing, especially when it comes to legality and stuff, it's not very easy to read. I'm sure there's actually some white papers on how to license some products, so I can just let you know that VRA was a little bit on that track as well. We had to figure out what licenses we needed and how to do that. So that's one lesson I learned.
Going off of what Pierce said, it was such an enjoyment working with these guys. I've actually known Pierce for 2 years, but I just found out who Eric was and Forrest was this year. Kind of wish I would have known them earlier, but hey, we're friends now. And then we went out to Burger King a lot every Friday, and we were anticipating that once we walked through the door, they would just start dropping like 60 chicken nuggets in the fryer instantly, because that's all we ordered. A technical lesson learned is keep looking for a better solution. As we highlighted earlier, we found 2 solutions, and there's no ultimate solution, but there's ones better than the others depending on what your needs are.
Yes, working with people hours on end is a great way to get to know people. As for technical, communication is so important for it to be quick and easy, just to keep all of us connected. We actually adopted a program which none of us had ever used before called Slack, which just allows us to keep connection with each other as well as message back and forth. And it let us share some memes with each other to keep us in high spirits.
Finally, keeping a project focused is kind of important, and you figure it would be for Capstone. But we had a lot of frequent meetings, both at our local establishments and with our Capstone sponsors. They allowed us to express our concerns and get direction if we needed it, to maybe shift focus if we needed to, or really hammer out the details when we needed to. So thank you for that.
Yeah. So throughout the semester, like I said, Kevin, we met at Burger King, pretty often. We went to other establishments too, and we couldn't have done it without them, thanks to the performance-enhancing resources that we're using. So, B-Dubs, Taco John's, Burger King, Silver Dollar, they were there when no one else was. But with that being said, that concludes our presentation. Thank you very much. We want to thank UW Stout as a school for providing us, the learning opportunity that we had. Thank you to Holly very much for being the program director. And as you guys saw today, she's doing everything she can to keep the program moving forward. So I appreciate that. Thank you very much to Dell EMC again for the upteenth time. You guys are fantastic to work with. And yes, thank you all for coming today.
Thank you.
Does anyone have any questions for us?
Why not? Sorry. Why not use OpenStack to back VRA? Why ESX?
So we decided to pursue VRA specifically because it was so ingrained with the VMware family and VMware ecosystem of products. OpenStack was a viable solution for us, and it still is. I think that everything we covered today would be accomplished with OpenStack. I just unfortunately think that we wouldn't have had the time to kind of tackle that learning curve of using OpenStack. None of us really had very strong scripting backgrounds or Python backgrounds for that matter. So I think what we decided to do was pursue this option, just in the interest of time, mainly. Any other questions? Yes.
Can you go back to your hours chart?
Yep.
From a project management standpoint, can you think of a reason that somebody would want to know how many hours you spent on a specific task?
On a specific task?
Yeah. So I think you went through and you described it all very well, what you did and how much time you spent on it, but actually having it laid out in numbers, probably from a billable hours standpoint.
Sure.
Right?
Yeah, absolutely. Yeah, we were tasked. We do have that information. We actually kept a pretty detailed timesheet of what we did during each day through the semester. I think we just summarized it in terms of weeks in this period, but
Right. But in
from a project management standpoint, I can absolutely see that. Yeah, how long did it take to do this task, and maybe if it's common to achieve it faster, what kind of held you guys up? So I can definitely see that being up there.
Great.
So obviously we're a storage team. So what are you guys using as far as the are we using multiple volumes, individual volumes for each individual person, things like that, or is it one large volume?
Currently, we're using a large volume that's connected to a business group. Since Vinny is a sysadmin, we've allocated, I think about 500 gigs to that business group, and they can just use that for their deployment. But you can go as granular as assigning that business group to a single user and specifying that they only get like 50 gigs, and then they would only have 50 gigs to go to their VMs.
Kind of a note on that too. When we went through the live demo and we went to that storage tab of that VM, I don't know if anyone saw, but it did say where that storage was located. It was located at SAN_VRA_sysadmin. So that means that because Vinny was a sysadmin, that's where that specific VM lives in a matter of storage. But if Vinny was a developer, then he would actually be, that VM would have been on the developer's volume on the SAN. So that's kind of how VRA handles storage. They handle it per business group, unfortunately not by user. But if you make a business group for each user, you could, there's a workaround there, but maybe that'll get hectic, I'm not sure.
Do all the standard functions of ESX and vCenter still apply? Like an admin of vCenter can go in there and migrate it around and edit it, delete it,
Yes.
do stuff in the background?
Yes, so that, when you console into the VM from VRA, that opens that HTML5 session actually to the host that it's living on directly, because that's how VMware handles, I guess, that console interface. It goes directly to the host. So yeah, if HA, or if a host fails and HA spins that up on a different host, everything will still work fine. And then yeah, if the vCenter admin wants to not use the administration side of VRA, but if he loves vCenter, he can log into vCenter, he can make all of his hardware changes there. And those values are reflected in VRA when it does. We set up to do hourly, they call it collections. So it'll collect all the information from vCenter and update VRA. Anything else?
Yeah, I know we talked about this previously, and I know we've addressed it and talked about it. One of the things we were interested as an additional on this was when it was the potential to be able to deploy a ESX environment with multiple hosts connected to vCenter. And I know we had talked previously as to the difficulties involved with that. I know that we had talked specifically with that VMware stated that that's not necessarily a support configuration to be able to automatically deploy a host and have it joining the vCenter. So if you could detail that a little bit for
Yeah, absolutely.
just briefly.
Yeah. So one of our more complex blueprints that we did not showcase today, actually, we're in the process of actually documenting that right now for the purpose of the white paper. But one of the blueprints we had was deploying 3 ESXi nodes. So those were actually virtual machines. So when we deployed those virtual machines, we would have it spin up 3 ESXi instances, also a vCenter instance, and a Microsoft Windows Server instance. So that Windows Server instance would be pre-configured with DNS for that little layer 2 network, and then a vCenter would then stand itself up, or it would turn on. It would automatically be configured with the host name and everything, so it would interface with DNS. And then one of the tackles, or one of the challenges that we had were getting those ESXi nodes to automatically join vCenter. So VRA works heavily with vRealize Orchestrator. I'm not sure if any of you guys are familiar with that, but that's kind of a more, I guess, granular take on how to achieve tasks using automation, using scripting and everything like that. There was a workflow defined for having ESXi automatically join to vCenter, but unfortunately what was not supported was every time that ESXi would be deployed, it would generate a new unique ID, which we would want it to, but then that would also reset the SSH footprint, or thumbprint rather, and then when it tried to join the vCenter, it wouldn't accept that automatically. That was on purpose, so that way there was no security vulnerabilities in there. So we actually couldn't achieve in the end the automatic addition or joining of those ESXi nodes into vCenter. We could through some more scripts, it'd have to be like a manual entry, but we kind of just ran out of time for that.
Yeah, we did discuss that as we used scope creep.
Yeah, the scope creep. And if that deployment is being used by someone who's familiarized with vCenter, adding a host to vCenter is just a couple clicks. Just put in the IP and the password.
Exactly.
So that's kind of the solution then.
Now, you touched on UUIDs as well. When you're doing deployments with other VMs, why is that so important?
Yes, so the unique IDs for ESXi, especially if it's going to be joined into a vCenter, is that it actually doesn't use IPs to uniquely identify ESXi. It definitely uses a unique identifier that's so many characters long, because IPs can change on hosts pretty dynamically. So a challenge we had was we couldn't just simply take an image of ESXi and turn it to a template and then, hey, deploy that template 3 times on the same network. And no, that did not work well. It also didn't work well from a storage standpoint. So every single file system that's on that ESXi host actually has to have a file system unique ID, which we didn't know about either until we started to create data stores on the ESXi host. And then all of a sudden, the host would pink screen and say, there's 2 file systems with the same unique ID detected halting system. So, that was just another little challenge that we had to overcome, and we found that having unique identifiers is important. Any other questions? I think in the interest of time, we'll hand it off to the next team. But if you have any questions, feel free to approach us after all the presentations, and we'd love to hear from you guys.